So I remember when I was doing the voltage episode, I was connecting a LED directly to a 9-volt battery and it totally got fried. Now let's try that again. Same 9-volt battery, different setup. And just like that, we got lights. That, my friends, is the power of resistance. Let's get into it. Yes, people, welcome to Teaching Myself Electronics. This is episode 8, part 3, resistance. Yeah, it's been a journey so far. We have already covered voltage, current, and it's time for my favorite, resistance. But before we get into it, I would absolutely appreciate it if you would hit the like button, subscribe, turn on the notification so you don't miss an upload. Thanks in advance. Really appreciate it. Let's go. So what is resistance? Resistance is just the opposition flow of electric current in a circuit. It can also be defined as blocking or slowing down electric current. The greater the resistance, the less current will flow and vice versa, just like water in a pipe. And yes, I know, I love my water analogies, but this is how I find to understand these terminologies pretty easy. So just as water in a pipe, the way the water flow, if you have a shut-off valve, the more you turn the valve to shut it off, the less water will flow. Same thing with electricity. The higher the resistance, the less current will flow. To achieve resistance in a circuit, we use components called resistors. And resistors are just electrical components that are designed to create resistance in a circuit, pretty much to control and limit the flow of electric current. We have many different types of resistors, and I remember resistance is the easiest property when you're talking about voltage, current, and resistors, but easy in understanding what it is and what it does, just to restrict the flow and the amount of flow. But knowing the type of resistor to use and the value of the resistor to use, this is where it becomes tricky. So as you can see on this chart, we have many different types of resistors, but I'm only mostly familiar with the top two, the fixed resistors and the metal film resistors. And I can tell you that these are the two most common types of resistors that I'll be working with throughout my electronics journey, PCB boards, DIY projects, and all of that stuff. And these fixed and metal film resistors are like dirt cheap, very cheap. I think I got like 600 of them for maybe $2 or something like that on AliExpress. And every PCB project that you buy, you normally have these resistors coming in it. If you buy SMD DIY projects, you get some of the flat, thick film resistors. I haven't started to work with those as yet, but I have come into contact with the SMD flat, thick type film resistors, and I think when I start the more SMD soldering, I will work with those. And thinking about it, I think I do have a few of those SMD projects with some of these type resistors on them that I've seen. The truth is, I don't know if they are resistors or if they are capacitors, because I know capacitors and these type of resistors can look the same. But until I get to that project, for now, sticking to the fixed resistor and the metal film resistor with the color bands. And these color bands are what you use to determine the value of the resistor by matching the color code to the number and then do some calculations to get the actual value. Or if it come in a pack like this, if you have the pack, the number will be written on the package. So like this one is 330 ohms, that one is 1 kilo ohms, that one is 220 ohms, and so on. So this is something that I'm gonna demonstrate or figure out how to test the resistors and how to get the actual value. To be honest though, I'm not a fan of using the color codes and the color band to figure out the value of the resistor. It can be a pain. I 100% prefer to use a multimeter. I'm going to show both ways, but I 100% prefer to use a multimeter. But before we get into understanding the value of resistors, how to measure resistors, all that fun stuff, let's take it back to the bench and do some resistance demonstration. Alright, so I have a simple circuit here, some wires, a LED and a battery, wires soldered to the perf board, LED soldered to the perf board. I have two AA's that I use to make a battery pack, so I'm getting 3 volts from this battery pack here that I made. The LED needs 2 volts or 2.2 volts, so the battery pack with 3 volts should be sufficient without damaging the LED. So connecting the LED to the battery here, light up, looking good. The circuit is working. So now I'm going to do a quick test of the voltage to see how much voltage the LED is using. So 2.53. So it's getting even more than what the data sheet would say. And this is one of the things with LEDs, they don't have any resistance in it. So whatever you connect it to, it will just pull as much current as it can until it burn itself up. So the battery pack is safe. 3 volts is good, no damage. Now I'm going to connect the 9 volt with the same LED and see what happens. Well, I did demonstrate this earlier in the intro of the video. 9 volts, the LED needs 2 volts. So it's going to get like 7 additional volts to the LED and eventually it's just going to fry. Alright, I just tested the 9 volt battery. I got 8 volts on it. Now I'm just going to connect the LED wires to the 9 volt battery. And just like that, the LED is fried. So the LED is totally burnt out now. If I try to connect the same battery pack, the 3 volt battery pack to the LED again, I should get nothing because this LED is dead. So we had 9 volts going to the LED that can only handle 2.2 volts, or well, it did handle 2.5, no more than 3. So it got a charge of 7 extra additional volts to it and burnt its core. Okay, so we already know that the 3 volt battery pack work with the LED without damaging it. So now we need to change the setup a bit and add a resistor to use the 9 volt battery to work. So right here I introduce the resistor on the positive side of the LED. It could be on any side, it doesn't matter, it works the same way, but I prefer it on the positive side. So the setup is simple, it's just basically have the resistor soldered to the positive side of the LED, and then the other side of the resistor is connecting to the battery soldered to the perp board with a wire. So now I have the wire going to the battery. On the negative side of the LED, I have a wire soldered going to the negative side of the battery. Ready to connect? Alright, let's do it then. We have a red wire for positive, the black wire for negative. I'm going to connect the black wire now. Black to black. Boom, there we go. We have light, continuous light. It's not flickering, not burning up, just staying on continuously. So thanks to the resistor, we can use this 9 volt battery to power this LED without burning it up. So now I'm going to do a quick voltage test just to see the resistor in action. I'm going to check again how much voltage coming from the battery and how much the LED is using. Testing the battery directly is giving me 8.6566 volts. And we already know that the LED cannot handle that much voltage. So now let's actually test the LED to see how much voltage it's coming through behind the resistor. So the LED with the resistor right now is pulling 1.91 volts. And I remember before when I tested the LED without the resistor, I was getting like 2.85. So this right now is showing you that the resistor is working. And it's based on the value of the resistor, which determine how much voltage and current it will restrict. And this is where values come in. This is where the value of the resistor come into play, because the value determines how much current will be restricted. So if I had used a higher value resistor, it would resist more current, so the LED would have been dimmer. With a lower value, the LED would have been much brighter. Also, a lower value can result in the LED burning up. If the value is too low, too much current will go through, more than what the LED can handle, and that's what cause it to burn. So how do we know what value resistor to use for what project? For example, for this LED project. Well, for this LED project, I got lucky. I got a PCB project with some resistors in it. I pulled one out and I just soldered it to the board and I locked out and it worked. But generally, you would use Ohm's law to find the value of the resistance once you have the other two values like current and voltage. This is how you use Ohm's law. So if you want to find resistance, it will be resistance equal to voltage over current. And you do the calculations, the value that you get will determine the type of resistor you use. I did Ohm's law in the current series previously, so check that one out. So before we start measuring and finding the value of the resistors, let's see the resistor in action again by using a device that was specifically designed to teach Ohm's law and how resistors work. In the last video I did, my first PCB disaster, I put together this PCB project that I bought, and it's a very good demonstration to show you exactly how resistors work by using LEDs, different value resistors, and a dip switch. So I'm just going to start off by just turning on some of these LEDs by using the dip switch. And you notice LED 1, 2, 3, 4, 5. You notice 1 is very bright, 2 is bright, 3 is bright but not as bright as 1 and 2. 4 is bright, and down the line it's just getting dimmer. And if you remember the diagram, it have from 330 ohms, and then the ohms, that's the value of the resistor, keep increasing. So the more resistance we have, there's a less current. So the LEDs are dimmer, and with the less resistance, which is LED 1, 2, 3, 4, for example, those are very bright. So if I should go ahead now and test each of the LEDs to see how much voltage each is using, we'd notice that the one with the brightest LED would have the most voltage. It's kind of difficult to test current from this point because normally you have to break the circuit and let the current run through the multimeter. So it's easier to test voltage, and resistance is actually restricting current flow, but it also gives you a drop in voltage. So right away you know that the LED, the resistor is working, and these are connected using a 9-volt battery, and they're not burning up as I did demonstrate earlier. Alright, so I'm going to do a quick test starting from the 8th LED. That one's running with a 47k resistor. So that's a 47k, which is like 47,000 ohms, because 1,000 ohms make a kilo ohm. So testing the voltage for this LED that's running with the 47k ohms is giving me 1.64 volts. And that explains why the light on the LED is so dim, because the resistance in the resistor is high. So the one beside it, which is a 22k, is giving 1.67, and then as I go up the line, I get 1.70 volts. Alright, let's move up the line a bit. The very first one is using 1.82 volts. Small increments for a few of them, but as we move up the line, the voltage increase, and this is primarily the job of a resistor. So about the values for the resistors, these resistors that we're using with the stripe bands around it, these are the values that as I said earlier. There are 3 ways to know the value of the resistor, and the first way, the simplest way, is if you buy it in a package and it comes on the package, it will show you. Like I did explain this earlier in the video, the number will be on the package per resistor, like 100 ohms, 330 ohms, 1 mega ohms, and so on. That's the first and the easiest way to do it. The second way, you would have to use a color chart, and the third way, you use a multimeter. So using the color chart, you normally have commonly 4 bands and 5 bands resistors that have the colors around it that represent a number. So each color around the resistor holds a value. So looking at, like, for the 4-band resistor example, the first band, the second band, and when I say band, I mean the stripes around it. These 2 digits, you put these 2 digits together. The third band will be the multiplier, and then the 4th band will be the tolerance. So the first example here, we have brown, black, 1, 0. 1 and 0 is 10. No calculations, no multiplication, no plus. Just put the numbers together. 1, 0, that's 10. And then if you look in the chart, it's the multiplier for red, which is the third band, is 100. So it's going to be 1 and 0, which is 10 times 100. And for this one, we get 10 times 100. It's 1,000 ohms, which is equal to a kilo ohm. And then the tolerance now, and this is something that used to confuse me, because I used to say, why the tolerance is a plus minus. But what it simply means is that resistors have a minimum and maximum level, and it can be anywhere in between. So to find the tolerance here, it would be, it's 5% of the 1,000. And 5% is, that's 0.05. So doing 5% of 1,000, that's going to give you 50. So that's going to be 50 ohms. And so now we need to find the minimum and the maximum. So the minimum will be 1,000 minus 50, so it'll be 950 ohms, or the maximum would be 1000 plus 50, so it would be 1050 ohms. So this is how the resistors work. It have a tolerance level of minimum and maximum, so anywhere in between. You can use a resistor value of anywhere in between 950 and 1050, which is 1050. Similarly with a 5-band resistor, same thing, but it's just that you have an extra band. So you have the first, second, and the third, and the fourth band would be the multiplier. Same thing applies. Alright, so like I said before, I'm not a fan of using the color code, even though it's the most accurate and it can give you all the details you need in terms of the tolerance and so on. But one of the problems that I find with it, when you're looking at some of these resistors, it's hard to tell which stripe is the tolerance and where to begin from which side, even though it says the tolerance is normally spaced further from the rest of the bands, but sometimes it's hard to tell. So not my favorite way to find resistance values. This is how I do it with the multimeter, and this is the best way that's been working for me. So using the multimeter to find the value for the resistors, it's just a matter of putting the multimeter in diode mode. And when you have it in diode mode, this is where you get the beep when you join both probes together. But one thing that I found out is that in diode mode, it can't test for resistors higher than 1 kilo ohm or 1000 ohms. So resistors that are like 10 ohms, 100, 300 ohms, 330, so on, you get a reading. But when you reach like above 1000 ohms and go up to like 2000 ohms, 200,000, 20,000, you won't get a reading. And this is something that was confusing me, because I was saying, why these resistors are reading, why are these not reading? But later on, I figured it out that you have to turn the dial each time based on the value that you are testing. But what if I have a resistor and I don't have any labels for it? It's not on a circuit board that's labeled, and it's not in a pack that's labeled. How would I find it? Same thing applies. I would just start from diode mode and go work my way up with each dial. So go to diode mode, then to 200k, then to 2k, 20k, so forth, all the way up to mega ohms if you have to. And that's how I would find all the values for the resistor that I'm working with. Yeah, all right, so that was quite a bit of information. So I think I'm going to wrap it up here for now for this episode. First of all, thank you for staying with me to the end of the video. I appreciate the support. Keep it coming. I really hope this video was helpful and you learned something from it. The journey continues, and for me, I feel like I am getting better and I am learning more about electronics. But this is still just the tip of the iceberg. There's so much more to learn. I'm going to start focusing more on PCB projects and building some DIY electric projects. So make sure to hit that subscribe button. Don't forget to turn on notifications so you don't miss the next upload. We have some interesting things coming out. So once again, thank you for watching. My name is Lex. So until next time, big up yourself. Peace out.